Look up at the night sky, and it's easy to assume that past Earth's atmosphere, you enter a featureless, infinite vacuum, a quiet, empty dark. In reality, space is partitioned by invisible walls, turbulent magnetic force fields, and massive gravitational traps. To map our actual place in the universe, we have to push outward from our planet and break through three distinct extreme physical barriers: the solar, the stellar, and the galactic. The mechanics of these boundaries define the physical environment between the stars. The first boundary sits billions of miles past Neptune. It is called the heliopause. Here, the stream of charged particles constantly blowing off the sun slams into the opposing pressure of interstellar plasma. As the solar wind hits this wall and decelerates, opposing magnetic fields twist and snap together in a process called magnetic reconnection. This creates a highly charged, chaotic barrier of magnetic bubbles known as the foamy zone. Only two human-made objects have ever punched through this shield. NASA's Voyager 1 and 2 probes crossed the heliopause and physically measured the environment on the other side, confirming that interstellar space is filled with a plasma that is significantly denser and colder than the material inside our solar system. Beyond the magnetic shield, we remain within the sun's gravitational reach. To leave the system, you have to cross the Oort cloud, a spherical shell holding trillions of icy comets that extends up to 1.6 light-years outward. This chart scales the Oort cloud against our inner planets. Notice this asymmetrical orbit. Based on mathematical anomalies, there is a 7% probability a massive Neptune-sized planet hides in this icy shell, captured by our sun billions of years ago. Slipping past the outer edge of the Oort cloud marks the transition to the interstellar medium, where the sun's gravitational influence finally yields to the wider galaxy. Past the Alpha Centauri system, we enter the broader environment of the Milky Way's Orion Arm. This 3D topographical map plots our surrounding stellar environment. We are sitting inside a 1,000 light-year wide cavity known as the local bubble. The gas density in here is roughly 0.05 atoms per cubic centimeter, about 10 times thinner than the dense galactic medium outside the wall. This vast void was carved out by immense violence. Roughly 15 to 20 million years ago, a cluster of massive stars detonated in a chain reaction of up to 20 overlapping supernovas. The combined force of those shockwaves swept the surrounding interstellar dust and gas outward like a cosmic snowplow. Our solar system drifted into this clearing a few million years ago, allowing us to navigate space without plowing through thick, hazardous cosmic clouds. This stellar neighborhood is a hollowed-out clearing, a legacy of dead stars that continues to act as a protective shield. Beyond the local bubble lies the entire spiral disk of the Milky Way galaxy. This visual compares our galaxy's visible swirling disk, spanning 87,000 light-years, with its true gravitational footprint, a massive dark matter sphere extending 2 million light-years. We remain tethered to the local group by an 800 kiloparsec connection line to Andromeda, binding our dark matter halos inescapably. Both galaxies are part of the Laniakea supercluster, an immense web of 100,000 galaxies spanning 500 million light-years. By mapping peculiar velocities, the actual physical motion of these galaxy clusters, astrophysicists found that everything within Laniakea is flowing together. We are sliding down a gravitational slope toward a massive, dense region known as the Great Attractor. On the highest scales, galaxies flow along gravitational slopes, pulled like liquid through the massive filaments of the cosmic web. Tracing this journey back down places Earth at the center of a nested hierarchy of physical protective layers. We are wrapped in a turbulent magnetic shield, encapsulated by a spherical cloud of comets, and drifting through a supernova crater as we flow through a galactic supercluster. This timeline correlates Earth's historical mass extinction events with our solar system's vertical oscillations through the Milky Way's disk. As we bob through different galactic densities, our magnetic shield fluctuates, altering incoming cosmic radiation and driving long-term climate shifts. By mapping these invisible cosmic walls, we see the true architecture of the void. We understand exactly where we are and how we are sheltered by the physical boundaries of the universe around us.